Yeah, I mean, that's a really good question. So people use codes like this to measure how clouds move. And they call this remote sensing. So there's satellites that orbit the Earth and take pictures of the clouds. And usually you don't use particle image velocimetry for clouds, but there's a related technique called optical flow that if you can see the same kind of information, a sequence of snapshots, you can run an optical flow algorithm on this collection of snapshots and back out the velocity, how the cloud moved between the pictures. So you're right. I mean, I don't know that anybody's done that with the oil slicks. And I don't know that it needs to be done, but it could be done. It's a good observation. Other questions? So let's come over here. Yeah.
Did your group take into account the compressibility of hydrocarbons at that depth? Yeah,
so the compressibility of hydrocarbons. I was worried that somebody who knew something about hydrocarbons would show up. So yeah, I mean, they are surprisingly compressible. I was in fact very surprised to notice that, to be made aware of that. I'm not a petroleum guy by any means. And so we had on the flow rate technical group a couple of experts on petroleum and material properties and so forth. And so apparently the compressibility is something like 35% from sea level, sea floor conditions to ambient conditions. So the answer is we did take that into account, but not because I'm such a smart guy. Yeah. There was something else, yeah.
Yeah, I just wondered if you could comment on the flow is multi-phase, and just in general, what problems everyone experienced, not just your group, but other groups as well, and what volume fraction is methane versus gas.
Yeah. So the question is, how do we deal with the multi-phase nature of the flow? And I showed you in one of the movies, and everybody's probably seen this movie. There are periods when black stuff comes out, and it comes out kind of slowly. And then there are periods when these white clouds come out, and they're coming out much more rapidly. And the black stuff is oil, and the white stuff is methane. But it's not quite as simple as that, because at this depth, at seafloor conditions, so underneath a mile of water, the pressure there is something like 3,000 psi, really high pressure. So even in the stuff that appears to be black oil, there's a significant vapor content. Some of it's dissolved into the oil, and some of it is small bubbles that travel along with the oil. And as the oil bubbles to the surface, the methane separates, and this was the gas-to-oil ratio that I mentioned previously. So the fact that this is multi-phase is a big deal. It wasn't such a big deal for the PIV, because what we did was we looked at the times that appeared to be all oil, and then we could use the gas-to-oil ratio, which is a property of the oil in the reservoir, to account for the fact that most of this, what appears to be oil, would actually turn into methane as it bubbled to the surface. Now the DOE group, what they did was they measured pressure between the inside of the cap and the outside of the cap, and then they have to do a complicated calculation for what flow does that pressure difference generate. And that is really hard, especially with multi-phase flows. You don't know, if you have a distribution of tiny bubbles versus a few large bubbles, the flow is entirely different. So I'm not sure how they dealt with that. I wasn't on that team, and I'm glad I wasn't. Other questions? Anybody? Yeah, right here.
Yeah, when you were meeting with the other groups, did you hear, in the media reports I've seen, there's been conflicting information on how much is on the surface versus how much is just kind of in there underneath the water.
Yeah.
While you were meeting with these other groups, did you get a feel for what's going on with that?
Yeah, so the question is, why do the numbers, the amount of oil on the surface, why does that disagree with the amount of oil that we see coming out of the pipe? And that's a very good question. And there's a number of aspects to the answer. None of the answers in this problem are ever simple. But some parts of the answer are, first off, the oil on the surface is a long time record of the emission of the oil from the well. So it stays on the surface for days and days, unless we spray dispersants on it. That's another issue, environmental impact issue. But the oil stays on the surface for a certain amount of time, and eventually the volatile hydrocarbons evaporate and it starts to sink down below the surface. So the flow rate technical group had another team besides mine that looked at the oil on the surface. And they came up with a number that was, the last number that they had was 12 point something thousand barrels a day up to 21,500 barrels a day, which is distinctly lower than the underwater estimates. And another part of the answer for why those are different is that this oil is underneath a mile of water. So, you know, oil is buoyant, it's less dense than water, so it's bubbling up. As it rises to the surface, the seawater is pulling on it, trying to keep it down. The oil is trying to go up. That's shear stress. And that pulls the oil into smaller and smaller droplets. So there's some conjecture that large quantities of oil are stuck underneath the ocean. So oil, not all of the oil actually made it to the surface. And there's actually, you know, it goes on from there, but I think that's a good first cut at an answer. I think we had a question here.
You were talking about the length of time and so forth that we may be spewing here.
Yeah.
Taking your flow rate, has there been a look at what the geologists figure that the maximum oil containment in this pod is?
You mean, yeah, so how much oil is in this under the sea? Yeah. So I would suspect that before BP spends $1 on drilling anything, they know what's in that reservoir, with seismic imaging and so forth. So they have a really good idea what's in that reservoir. I haven't heard that number.
50 million barrels.
50 million barrels?
That's what Tony Hayward quoted today.
Okay, yeah. So Tony Hayward was being grilled by Congress today. And so 50 million. So I don't know what we're at now. But you could work out with that 60K barrels per day number how long you would expect it to run. 60,000 per day. Okay, 2.5 years. So I mean, if these relief wells don't work, that's a first cut. That's not exactly the right answer, but that's a first cut at how long this thing could run on its own. A question here?
So nothing's being injected to replace this. Has anyone done any calculations on the extent to which the Gulf floor will sink?
I don't know. I mean, that would lower sea levels, which people in Louisiana would be happy about. I think on a global scale, it's probably nothing. Rounds to zero would be my guess.
So not the sea level, the floor itself.
Yeah. When the floor drops, I mean, ocean water would fill that pocket. You'd get a drop in the sea level, but I don't think it would decrease immeasurably. Would be my, you know, the volume of the oceans is so huge. Tony Hayward said that.
I'm wondering how far the floor not the water itself.
Yeah. Well, no, I don't know how much the floor would drop, but I don't think it would be, you know, if you were pulling reserves out from underneath New Orleans, you would be really concerned with that. But I think since it's the bottom of the ocean, it probably doesn't matter a whole lot. Let's see, there were some questions way in back. Let's go way back there. The guy in the 56 shirt, no. Oh, okay.
So I wondered if you could attribute the difference in your original numbers of 7,000 down to the lower numbers, even though I would assume rate of flow had been cut off. Is that due to the higher resolution videos that now work?
Yeah, so the initial measurements that I made were based on 30 seconds of what I'd say probably only at a bar, crap video. You know, that's what BP posted, and that's what they expected to, that's all they expected to post, was this little video that shows what the flow looks like. And they didn't tell us a whole lot of information.